Alors, bonjour tout le monde, ça va bien?
Ça va?
Maybe my French isn't good enough, I'm sorry. I switched to English now, okay? Maybe my English is not good enough either, but it's better than my French. Okay, so let's try that again because it's a really, really boring topic, right? So we really need your love and your help and your support. Bring some love and enthusiasm into this room, okay? So let's try that again. Hello, everybody. Hi. Hi. Ah, that works. That's awesome. So that's Thorsten from ThinkTecture.
And this is my colleague Christian from ThinkTecture. Let's enjoy the upcoming 25 minutes where we want to show you how to build modern business applications for any platform, the web and native integration based on Angular 2. This is a worldwide tour with full throttle, so fasten your seatbelt.
Okay, fasten your seatbelt. That sounds scary. So you could fasten your seatbelt, but at the end it's still a boring topic, right? And it will be a boring session, I tell you, because there is no 2D or 3D visualization. There is no lightning bolt which you can remote control with your Angular app. There's just really nothing like that. It's just about business application, okay? The idea is that we want to talk about how to today build modern business applications. Modern business applications starting in 2016 and maybe 2017, where you are building the next generation of your software. And we want to build that with Angular 2, of course. A lot of our customers are going that route. Our customers are coming from a typical desktop environment, from .NET and from Windows setups, and they want to go real cross-platform with the next generation. So they build Angular 2 applications, but still want to be able to move on to the mobile platforms and to integrate with them. They want to be able to move on to the desktop platforms and to integrate with them. So that is the basic idea, to have a web app in Angular 2 and to create from the web app an app. Okay, so a web app to a mobile app and from the web app to the desktop app. That's it. And ideally, all with one code base. So we think about the potential use cases, the potential operating systems, the potential platforms and target form factors of our clients and customers' projects. So we need to think about how we actually can do that, not just mobile. Well, of course, we need to do mobile. We do mobile first, but mobile first is not mobile only, okay? User experience is very, very important here. If you want to do everything with one code base, you can imagine that user experience is really important because we need to optimize the user's experience for the smartphone, for the tablet, and for the desktop, and maybe multi-monitor desktop, okay? So maybe the standard approach that we know of or that we have been using for the past years is not good enough. Usually, we really invest quite a lot into the whole set of analyzing the user experience, the use cases, and then building optimized user interfaces. And let's do that. Let's just take an existing sample web app. So we have a small web app which we want to take to a mobile app and to a desktop app. Let's do that. That's a small sample application, and it's called Hacks. And Hacks is a management application for hackathons. So if you want to create a new hackathon, or if you want to organize a new hackathon, you could use that application. It has some prototypical use cases we are facing in each and every business application in our client's world, more or less. So the first one is authentication and login. So we are going to log into the application. We're using an open source identity provider here called Identity Server, which uses, in this case, the OAuth 2 implicit flow. And then we have the first screen, which is a dashboard. And that dashboard, at the end, shows the master data. So a list of cards of hackathon information. This is optimized for the desktop. If we are now trying to make the window a little bit smaller, we can see that we, of course, have a responsive approach to everything. Now we have a list, yeah? And if we go even further to the smartphone form factor, we can see that the entire navigation UX is changing to be mobile optimized so that you can use your thumb and then you can actually use your left thumb or your right thumb to to press or to push the buttons on the bottom, and we have a slide in and a slide out menu. What else do we have here? We can go to the details, of course, of the hackathons. So we have a form here with some controls, so pre-built controls or custom-made controls. In this case, just for the desktop. Let's go to the profile. So each user has a profile, and here we can do multi-language. So obviously, we only have English and German because we can't speak French, as you know, just a couple of minutes ago. That's all based on a very simple approach by using JSON-based metadata to do the translations. And last but not least, we had structure data with master and detail views. And of course, we also have binary data. So let's take a profile picture of Thorsten. That's not too bad this time.
Works.
So here we are using the desktop camera implementation running inside of Chrome, and you can now send it up to the API to update your profile. So the application architecture is a distributed application architecture. We have the single-page application running inside the browser, and of course, we have some web APIs sitting on the server, which are protected by JOT tokens, which are being emitted by an identity provider. So quite a common architecture in place here. But yeah, that's nice, okay? Yeah. It's nice, but we want to go to the mobile app. So let's use Apache Cordova to create an app now. So we are going to just take the existing web app, and we are going to move it onto the mobile platforms. So Cordova, at the end of the day, provides us with two things. First, a tooling and a CLI, and then also an API and plugins which we could use to talk to the native platform. So first we need to create a project, a Cordova project. A Cordova project is some kind of a meta-level project, okay? And based on that meta-level project, we need to add the platforms that we want to use. So we want to use, of course, the world's most important mobile operating system, Windows 10. Then we use iOS, and then we use Android, okay? And after we have added those platforms, we are also going to use a bunch of plugins, standard plugins that are already in place because you just need them, like the splash screen for your app, like the status bar to configure and to manipulate the status bar, for example, on iOS. Are we done with that?
Yep.
Wow, that's cool. So let's take a look at what happened. So there has been some things being generated, and one thing is a folder with the platforms in it, so iOS, Android, and Windows. But then we have one metadata file which is very important, which is the config.xml file. The config.xml file contains the necessary information, which is then be used by the Cordova tooling to create native artifacts for each and every platform. Okay? So parts of it are just put into the AP list on iOS or into the Android manifest, for example. Let's start with some more preferences. We come back to that in just a second, and let's start the build. So the build is all GulpJS based, because that's a proven technology and proven set of Gulp tasks that we have been using over the past years. And we are just aliasing them with some npm run commands. While that is building, let's take a look at those preferences. So we have some preferences that are for the status bar, like the color, like whether it should overlay the web view, the style, or we have preference for the splash screen, like the screen, the screen delay, the color again, and the aspect ratio behavior. And the last two lines are platform specific. Here we are instructing the Android SDK compiler which SDK version to use. So in the meantime, that build process should hopefully be executing quite successfully and should deploy the application to the simulator. So we should see an icon. We should see a splash screen. We should see a splash screen. And we should see the app. OK, so that's it. Here we have the optimized mobile view with the sliding in and sliding out menu, and it just looks nice. So that's just the plain app. That's okay, right?
Yeah.
But still boring.
Yeah.
Okay, let's go to Android. So for Android, we do a similar thing. So for Android, we also have a build command, start Android. And what this one does, it uses the native Android SDK compiler and creates an APK. And this APK is being deployed to the Android SDK emulator. Usually, we use a very special plugin in our applications that we are building for our customers, and this is Crosswalk. Crosswalk enables you to add a certain version of Chromium into your app package so that you do not have to rely on the older browsers on Android, right? So there you have all the nice features and all the latest and greatest stuff, and yes, you can be sure that the performance is much, much better than just having to rely on the locally installed web view on your Android device. And voila, the same application being deployed onto the Android emulator. So we're done. Well, oh no, wait, Windows.
Windows.
Okay, so Windows means, what is Windows? By the way, when we talk about mobile, so Windows is UWP, it's the Universal Windows Platform. And Universal Windows Platform means that it can run everywhere in the world where Windows runs. So that's universal, right? So it can run on Windows Desktop, on Windows Mobile, and on the Xbox. So our application can run on the Xbox, but Thorsten forgot to bring his Xbox, I'm sorry.
Sorry.
So meet us in the hotel after the conference, and we can try to deploy it there because they have an Xbox there in the lobby, by the way. Okay, so we need to copy it over. Cordova created the project on macOS, but we cannot compile and execute it, obviously. So we need to go over to the Windows 10 VM, and on the Windows 10 VM, we are going to open the solution inside of Visual Studio.
This takes some time.
And in that solution, we have 4 projects. One project is the Cordova project with all the web app stuff. We have a Windows Phone 8.1 project, okay. We have a Windows 8.1 project, okay. And we have a UWP project, so Windows 10. And we are going to use that. But first, we have to change a value because I have the HoloLens SDK running on that virtual machine. So we need to change it back. And after we change it back and after we compile the application, of course, we see a very nice splash screen in just a few seconds of time. And of course, we see the application running as a UWP now, all based on the same code. So we have a running version on Windows 10 Desktop or Windows 10 Store, UWP, on Windows 10 Mobile, on the Xbox, on the iPhone, on the iPad, on Android phones, on Android tablets. Yeah, that's fine, I guess. Yep. That's nice. But and I think you like it too, but you were just too tired. That's okay. No, it's okay. That's fine, yeah. But still it's boring. Still it's too boring because we did nothing spectacular yet. So let's get it a little bit more spectacular by adding more native functionality. And more native functionality means let's use Cordova plugins. And Cordova plugins can just be used by using any of those available in the big ecosystem of Cordova plugins or PhoneGap plugins. Let's do that. So we are going to use the mobile camera on the device, okay? Now it's getting scary. Let's take a look at the Angular 2 code. We have a camera.ts file there, and inside of that camera.ts file, we are statically returning the desktop camera service. So let's change that to use a factory, or to use a logic and algorithm to determine at runtime whether we want to use the desktop or the mobile camera service. Okay, once we change that, let's start the build. Now that build that we are using is trying to download the plugins. It's trying to build the application and then deploy it onto the phone, on the physical phone. Okay, that desktop camera, that mobile camera service, what does it actually look like and what does it do?
Yeah, so here's our implementation of the mobile camera service. So first, we use a simple configuration object to ensure a consistent user experience across all platforms, right? So after the point that we get back the local image URL, we hand over that URL to a dedicated plugin, the so-called file transfer plugin, which will upload the image to our protected web API.
Okay, cool. So, and that's all, 35 lines of code to support all, well, that's cool. So let's have a look at the build process. In order to be able to have a look at the phone, let's use Quick Start to project it onto the screen. And what we're using in there is an additional plugin called the WK WebView. So the WK, or the WebKit WebView controller, is an optimized WebView controller, which is quite similar to Crosswalk because it brings us the latest and greatest on iOS. It brings us JIT compilation of JavaScript, and it brings us a much better performance also with touch-enabled events. So we already see the phone up there. It's being deployed. And in just a few seconds, we need to talk a little bit slower so that the timing will be right. So here we see the Hex splash screen again. And after the splash screen, we see the waiting animation. And you know what? Multi-language works because it's my German iPhone. The German UI, okay? So let's try to log in. Okay. You need to be soft to it.
Yeah, thank you.
Let's try to log in with Thorsten's super secret account again.
Yeah.
We see the list of hackathons, and let's just go to the profile again. Let's do a selfie. Oh, wait, have you seen that? Well, you were too fast, my friend. The operating system has asked if we allow access to the camera from this application. So this is the mobile camera right now, okay? Ooh.
Should we upload it?
You don't want to use that as a profile picture, my friend. I don't think so. So, that's the mobile part. We use Cordova to move the web app to mobile app apps on iOS, on Android, and on Windows 10. And we use Cordova plugins to augment and enhance the app to provide us native features like access to the camera. We also have a splash screen and an app icon. So it's all in that build process that we are providing with this application. Mobile, yeah, mobile.
Done.
If you read the press, the word is all about mobile. Mobile, 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 mobile. Reality tells us desktop, desktop, desktop. Because we are really having a lot of work to do to build applications and to provide an optimized user experience still for the good old desktop. But still, we need to support the tablets as well and the mobile smartphones as well. That's why we are using this idea of one code base, but user experience and use case driven. So let's jump over to the desktop. And with the desktop, we can do similar things with Electron. Electron is being built by GitHub, and Electron is being used by large companies. So for example, Slack. Slack just updated their client last night, I guess, or yesterday. Yeah. And Visual Studio Code. So who is using Visual Studio Code? Okay, you were all already using Electron. Okay, Electron tries to marry Chromium and Blink on the application level, on the UI level, and Node.js on the lower levels in order to be able to talk to the local operating system. We can build applications for Linux, for OS X, and for Windows. Okay, so let's try that. In order to do that, we need at least a package JSON because it's Node.js based. So let's have a name property in there, let's have a version property in there, and let's have a so-called main property, and that main property points to a JavaScript file. And that JavaScript file, well, Thorsten always likes to call it the instruction file. So that's the epicenter of Electron world, right? So what does that index.js, in your case, actually do?
Well, so the instruction file is responsible for taking care about the entire application lifecycle. So if you execute the Electron app either on Windows, Linux, or macOS, this file tells the application how to behave.
Okay.
And so right here we have a really, really basic instruction file. It's just defining some metadata and teaching the window how big it should be. And what we're going to do right now is we take our existing web app and package it as a desktop app. So we can do that by just linking to the existing web app by providing the path to our web app.
So wait, you are just using the existing build folder, and then you are running some kind of
magic
container, huh?
Right, it's just a simple package that we are using. So we go into our Electron folder right here, and we're using a package called Electron prebuild and provide the path to our Electron app. And we see the splash screen, and there we are.
Okay, so thanks. That's already a running Electron application, but something is not okay. Something is wrong. Zoom into the upper corner. It still says Electron, right? And there's no real value add. I mean, that's nice, but still it's boring. Okay, so let's go a little bit further, because what we are now going to do is we want to enhance this application by using more native APIs and native features of the desktop operating system. And we want to automate the build process so that we do not have to do that manually with Electron pre-build. We want to have it all in one build process and build step done with the end result of the application. So let's try that. We are not going to use any node modules here, but we're going to use the Electron API. And for the Electron API, we can do several things, I guess.
Yes. So first, we will register a global shortcut on the operating system. So we have different shortcuts for different operating systems. And as soon as the user hits that shortcut, we will toggle, or we will show and hide the Chrome developer tools that were already built into Electron.
Maybe this is not a recommendation for production, but still it's cool.
Yeah. So right after that, we have, of course, to change the URL back to browse or to surf from the current directory, because we want to package it automatically.
Okay, so now we're using again the npm run commands, which are using gulp task, which automate the packaging. Okay, great.
Exactly.
If I could have a wish, what you should implement for me, may I have a tray app icon or a tray app at all?
Yeah.
So a tray app is what in macOS X is on the top, where you can have an icon and a menu, and on Windows it's on the right bottom side, right, where you can have an icon and a menu. Let's do that, because I think there is quite a nice API for that. Of course there is an API for that, as there is an NPM package for that. What we need is just a little bit of JSON to configure the menu. So we have two menu entries. One is for quitting the application. The other one is for executing a command. And this command should take us to the add new hackathon component inside of our Angular 2 application. So we are running a tray app on the tray, which is its own process, and we talk via IPC, inter-process communication mechanisms, to the main process, all in JavaScript. Should we try that?
We should try that.
We try that. Okay, we provide an icon, we provide two menu items, and we provide the build script, npm run build desktop. What we're doing there is we are taking the app with the metadata of the Electron folder, and we are building the applications for all three major desktop operating systems, and that takes ages. Oh, done?
Done.
Really?
Yep.
11 seconds?
Yep.
3 desktop apps?
13 seconds, yeah.
Okay. Does it work?
Let's give it a try.
Try it. So let's first try macOS maybe. Should be the safest. Not sure why, but just in case. Oh, look, there's a nice icon.
Yep.
Can you switch back to the Finder? There's a nice icon, and it's just a .app, and we're integrated with the menu. So just scroll up there or zoom in there. We have an about, and we have an icon, and we have an about dialog, and all is nice. Maybe you log into the application. Here we get a pop-up window in that case, as we got on the mobile phone as well. In the mobile case, we used the in-app browser plugin in order to provide the login view. And now if we go up there, we see the nice icon, the hex icon again, in the tray bar. And if we click Add New Hackathon, it talks via IPC to the main process running the main application, and it navigates to the new component. So cool. On macOS, let's try to run the application on Linux. On Linux, here we have a Ubuntu 14, and it's not that spectacular now because hopefully the demo works, and then it just works. If the demo doesn't work, we are the idiots, okay? But I think the demo just works. Okay, let's switch to Windows 10. And Windows 10 is kind of funny because you already saw the hex application, but it was just a UWP app. Now we get a good old school Win32 classic desktop app .exe, right? Because that's the real app. That's the real app. So you already did it.
Yep.
You already did it. So you already started it. Here you can see the .exe on the left side in Windows Explorer up here. And yeah, here we have the same experience, and we have the task bar item with the menu, and we could just log in again and execute the same commands. So we have now seen how to do it on mobile, and we have seen it on desktop. That was the native integration with Electron.
All right. So yeah, ladies and gentlemen, as Christian said, we saw that you can build applications for all platforms, desktops, mobile operating systems, the web platform with native integration, all on a single code base. And yeah.
And that's it.
Yeah,
yeah,
that's
right.
it, yeah.
So
no,
if you have any questions, you can come to us after the session. Please enjoy the following session, and after that, have a safe trip home, and thanks for listening. See you.
Thank you.